Hi guys, in today's video we're going to show you how to run vector error correction model as well as vector autoregressive model. We will start from showing you how to test unit root in series. After showing you how to test unit root in series, we will show you how to estimate a VAR model. A VAR model. After a VAR model, we'll also show you how to test cointegration as well as testing for lag structure. After cointegration, we'll show you how to finally run a vector error correction models. So you have your data imported from in EVIEWS. We have to, for example, to measure the impact of debt on GDP on growth. So as variable we have GDP, we have commercial openness rate, we have GDP per capita, we have inflation, we have the ratio debt over GDP as a variable of that we are going to use in our models. So the aim is to show to see whether or not debt have an impact on GDP. Is a macroeconomic model that we're going to estimate right now in order to make policy recommendation. So we first of all going to test for unit root test. Our first variable in the database is commercial openness. Open our data. We came in the tab view, and then we can, for example, look at graph of our variable. So we came on view. If we are going to test for unit root, we came for view, and we click on unit root test. Unit root test. So we can test for. We have the possibility of choosing many tests. We have decay Fuller test, augmented decay Fuller test. We have decay Fuller test. We have Phillips Perron test, we have KPSS test, and so on. So for this example, we will let the default value use, which is augmented decay Fuller test, and we can test for level. The first difference, we can test for second difference, stationarity. So we will test for first for level unit root test. So we click on OK, and we have test result. So we have a p-value that is higher, and if we fix the threshold of significativity of 5%, we can we can accept the null hypothesis, which is commercial openness rate has a unit roots. So our series commercial openness is not stationary. So let us back in tab view and go back on unit root test. If you choose unit root in first difference, we see that our p-value is smaller, so that we can reject unit root test, which is that our theory have unit root test. So as our theory is stationary in difference. So that's the result of our test. We'll let this variable, let us look at GDP. GDP, we came on view, unit root test. Back on first difference, okay, we see that our series GDP is not stationary because the p-value is higher than any threshold that we can choose for significativity. So we can look at the unit root at first difference. We see that our series is stationary even though we chose 1% threshold. So we do the same thing for GDP per capita view, unit root test, and in first difference we look at, we can see that our series is not stationary because the p-value is very significant. So we can look at first different tests and we see that our series is stationary in difference. So we can look at inflation. Inflation, we have unit root tests in different, and the unit root tests show us that at 5% level we can affirm that inflation is stationary because we reject the null hypothesis, which is inflation has a unit root test. So for now, only inflation is stationary among our variables. We look at ratio of debt over GDP, the ratio debt over GDP. We look at unit root test, and we can see that the series is not stationary according to the p-value. So in first difference, we can see that the series is stationary when we choose 5% threshold. So now that we have different unit root tests and the situation of each other variable, in our model we're going to test for the impact of debt on economic growth. So we're going to use GDP and ratio debt on the GDP as dependent variables, and other variables will be used as covariants. So when we want to estimate the VAR in EVIEWS, the first thing to do is to go in the tab quick and go to estimate VAR. So we're going to first of all estimate standard VAR. Our endogenous variable are, as I told you, GDP, and you just put a space and put as your second endogenous variable, which is ratio uh, ratio debt on the GCP, which is a variable that will be used to capture debt information on debt. Endogenous variable, we are going to put it in this interface, and you see that EVIEWS have chose the constant as a default endogenous variable. We let it like it is, and we will add other endogenous variable that will help us explain the impact of debt on GDP, on economic growth. So our first endogenous variable is GDP, commercial openness. So we will differentiate the commercial openness because commercial openness is not stationary. So let's notice that our variable GGP and depth are stationary at first difference. So we'll estimate first of all the VAR without before seeing if our two variables are co-integrated, if we are going to estimate an error correction model. But in endogenous variable, we will differentiate variables that are not stationary. So we differentiate the commercial openness. The second variable is GDP per capita. We also differentiate GDP per capita. And finally, we have inflation, which is stationary. So we will not differentiate inflation because inflation is stationary. So after introducing all these parameters, we just click on OK, and our VAR model is estimated. We can see the first equation, which expresses GDP in function of lab 1 and 2 GDP, and as well as ratio of debt over GDP with additional exogenous variable, which are differential of commercial openness, differential of GDP per capita, and inflation, that are our dependent exogenous variable in our model. So we have the R square, which is close to which is 99%. We have other estimate parameters. So we have the two equations, the equation of GDP in function of other variable, and the equation of ratio debt over GDP in function of so if you come back on estimation, you see that for default lag interval for endogenous variable is 1 to 2 lags. So we'll go to test the lag structure to see what is optimal lag that we need to introduce in our model in order to make it optimal. So we'll go in view and go in lag structure and choose the last option, which is lag length criteria. So in our model, we will put 3 lags and click on OK. You can put, for example, 5 lag, and you click on OK. So you will see in our model that the optimal lag structure is 2 here. The start mean that the optimal so we can come back on our lag structure. First of all, we will put 3 as a lag to introduce in the model, and we see that lag 2 is the criterion that optimize according to other the 2 lag is the best number of lag to introduce in our model according to various criterion that are sequential modified LR test statistic, final prediction error, Akaike information criterion, Schwartz information criterion, and Anand Quinn information criterion. So we will put in our VAR a 2 lag as is indicated by default by EVIEWS. So we have our VAR of 2 lakh that is estimated with the O ratio. As you know, our independent, our endogenous variable GDP and ratio are stationary, are not stationary, so we will test for cointegration of the two variables in order to see whether or not we will estimate a VAR model, so a vector error correction model. So we look at view, we go in cointegration test and we click on OK. So there are too many possibilities. So the default value is trend, intercept, no trend, in constant, and VAR and test VAR. So that there are too many options. You can put no intercept in your or trend in your VAR. You can have intercept, no trend. So you have to choose uh, different option among others. So we choose the option intercept in our theory and click on OK. So you should see that trace test show that indicate that there is one cointegrated equation at 5% level, which means that we will estimate a vector error correction model as well as far as there is a cointegration, one cointegration equation between GGP and the ratio depth over GGP. So now that everything is set, that there is error correction model that we are going to estimate due to the fact that there exists a integrating equation between GDP and ratio depth over GDP. So we're going to show you how to run error correction models. So we have estimate a VAR model. A VAR model, this is the equation of the VAR model. After that, we will just go to estimate and choose vector error correction. Vector error correction. Remember when we were doing a tutorial video on the theoretical part of vector error correction model. In VAR model, we saw that when we estimate a standard VAR and we are going to pass from a VAR to a vector error correction model, we differentiate our independent variables so that if our VAR were lab P, error correction model will be on of lab P minus 1, so that you know that we estimate a VAR 2 model, and now we are going to estimate a vector error correction model associated to the VAR model, so that we should estimate a VAR 1. So the lag interval is 1, 1, not 1, 2 as it was in VAR model. So we are in vector error correction model. We choose the option vector error correction model and we decrease our lags by 1. So we had VAR 2. Now we must have vector error correction model of lag 1. So after that is set, we click just on OK, and we have our VAR, which is estimated here, which give a R square of 98%, more than 98%. So we have cointegration equation, which is given by GTP minus 20008 0.4 time ratio debt over GDP plus a constant. This is cointegration equation that is used in order to express manual. We have the expression, the first equation that expresses the differential of GDP in function of cointegration terms and lack one GDP. And problem here is that we cannot use it in order to make to see whether or not each variable is significant, statistically influence significantly the dependent variable, which is the differential of GDP. So we estimate the error correction model. We estimate an error correction model in which we will estimate an error correction model in which a linear model, a linear model in which we will introduce every coefficient here and we'll look at student tests of each coefficient to see whether or not each coefficient is significant to see whether or not don't forget that at the beginning of this tutorial, I told you that we're going to evaluate the impact of debt on the economic growth, so that we choose as measure of economic growth the GDP and measure of debt ratio debt over GDP. So we have our co-integration equation. As far as co-integration equation appear in the linear model that we will express, we'll just generate the error correction term that we will use in our linear model. So we just go on generate, we generate co-integration equation, which is equal to GDP minus 2, this coefficient which is here is 20080.4 time the ratio debt over GDP plus the constant of the co-integration equation, which is 3784486. So we just click on OK, and we have the co-integration equation which is generated. And now I will estimate my linear model to better see significant and better use it in order to make maybe simulation or forecasting, for example. So I go on quick estimate equation, my linear model, the principal, the dependent variable will be GDP, not GDP, but the differential of GDP, because in VAR model we differentiate our dependent variables. So we differentiate the GDP as dependent variable, which is following by dependent, which are co-integration equation. You know that in VAR we make co-integration equation is lat. The second variable is the differential of lat GDP, lat 1 GDP, lat 1. The third variable is the differential of log ratio debt over GGP. The differential of log ratio debt over GDP. The constant and the difference other equation in our model, which is the differential of commercial openness, the differential of GDP per capita, and finally the inflation. So we have our linear model and click on OK. You see that our linear model have the same coefficient as in our VAR model, but we can observe the significance of each coefficient here, so that we can say that the cointegration coefficient is negative and significant, which is the expected sign. In error correction model, we have the lag GGP differential of GGP, which is not significant, and we see that the lag depth significantly influence on GGP, so that we can conclude that debts have a negative impact on influence significantly on GDP, and the impact is negative when we look at differentiated variable. So we can also see that in a variable that GDP per capita and inflation have significant impact on the GDP. Impact is just positive impact. So you can use it in order to make a forecast if we have correct prevision of variable like which are not lacked, such as commercial openness, GDP per capita, and inflation. So if we can make a prevision of commercial openness for the current for the next year. Also the prevision on GDP per capita and inflation, we can make a prevision forecast on different dependent variable. So that's it for today, and I hope this tutorial very what useful to you in the understanding of GDP in the understanding of VAR and VECM model. See you very soon.